Hello and welcome to Powering a Sustainable Future ESG Framework and Electric Grid course, when we'll bridge the gap between all the electric utility fields from generation, transmission, distribution, customer equipment, and how does this relate to climate change and sustainability. So just a little bit about myself, so you know where I'm coming from. My name is Ahmed Mousa. I've been in the utility business since 2004. I have worked for four very large utilities, Pepco in DC, First Energy in New Jersey, Con Edison in New York City, and PSEG in New Jersey, and I also support PSEG Long Island from case to case. I'm also the CEO and founder of two consulting companies. I do a lot of national and international work, electric bridge consulting, focusing on all matters related to the utility business and the energy business, and the 100% Energy Club, focusing on getting to the 100% energy, 100% clean and renewable energy system, which we will discuss in this course in details in a reliable, resilient, and cost-effective manner. I've also been very fortunate to have been an adjunct professor since 2004, since 2014 when I started NJIT, and I've taught my first course in Rutgers, working with two other professionals from sustainability. And I also started teaching at Columbia University. As you can see from the diagram, I do sit on several boards, including Smart Electric Power Alliance, SEPA, and I'm also their cybersecurity working group chair. I am the Emerging Technology Advisor for IEEE, which we'll talk about emerging technology as well. It's very important. And I do sit on the Pace University and Rutgers University Cybersecurity Group. Finally, I had the privilege of publishing several books as a request from my students at NJIT. So now that give you a quick overview of my background, we'll keep going. So it's very important. I remember back in the days when you mentioned to anyone that you work for the utility, all that goes in their mind is the meter reader. The meter reader, a person comes in, he or she would read the meter, and simply they would subtract the latest month from the prior month, and that's how much energy you have used, and you receive the bill for it. Since then, I think the utility business has been kind of stagnant for a while, and for the last 20 years, it became very, very popular, and especially the last couple of years. So what you see in front of you here, this is what was known as the inception or the good old days or the original system. If you go from the top left to the bottom right, and we discussed this in great length in the course, you could see the generating station. In this case, I'm showing nuclear. So everything starts at the power plant. That's where electricity is first generated. It could be a coal power plant, natural gas power plant, hydro, and nuclear. As you can see in this picture, natural gas, of course. It depends on the utility and how reliable the system is. The power plants could be in very, very remote from the load center, or like New York City, you could have several power plants like by the East River. And then you have to transfer or transmit the generated power over a long distance. If you've ever been to Niagara Falls, you'll see a lot of transmission assets that connects all the way from Canada and the border of the United States all the way to New York City. Hence, you need the transmission system, which are the massive transmission towers you see along the turnpike. And their main job is to reduce the losses and transmit the very large generated power to the load center. So they don't go, of course, straight from the generation transmission to your home. You have multiple substations along the way, transmission stations, switching stations, distribution stations, area stations, which we'll discuss. And then you start doing the opposite. So the transmission system, you would raise the voltage to lower the current. As you come close to the load center and to the customer, you start reducing the voltage to get to the point when you could basically plug in your phone, your laptop, and so forth. So it's a very, very long journey. You could see in the diagram here. So that's an inception. Why is it the inception? Why is it the good old days? Because if you look very carefully, you're not going to see solar energy, energy storage, onshore wind, offshore wind, all the electronics. So this is kind of, again, it's a different system. Some parts of the world, that's still the predominant system, but for many other locations, renewables are playing a big role. If you look at California, even Texas now, countries like Germany, Finland, Australia. So generation, they play a massive role. Renewable generation, I mean, and we have to basically ensure the system behaves in a reliable fashion. So I manage a group called Utility of the Future, focusing mainly in electric, but I also support gas and nuclear. So it's important for us to attain the 100% clean and renewable energy in a reliable, resilient, cost-effective manner. So again, it's good to look at this diagram from the top left and you trace like the lines up to the home and the business. So I would like to bring to your attention the energy journey. So again, I mentioned a few minutes ago that the focus, or at least the knowledge, or the relationship between customers and their utility is, you pay for your usage, and then after that, God forbid there's any disturbance or you lose power, that's when you call them. So those are basically, receiving mail and making a phone call if you lose power. That's as simple as the relationship. Now, of course, things change a lot. However, I think this slide is very important. So I'd like to discuss with you the energy journey, if you will. So everything started from safety. From day one, safety is the bread and butter for the utility, is the most important entity. Safety to the public, to the contractors, to the employees, to the wildlife, everybody pretty much. So you have to make sure the system is very safe. And then reliability is very important. Again, if you read about history, you'll know that there were two large blackouts that happened in New York City in the 60s and 70s. And right after that, the commissioner and the local basically political entity that regulates the utility, they forced utilities to design a more reliable system. So reliability became very, very critical. This whole thing about M-1, M-2, and so forth, which we will discuss. So again, you have safety and now you add reliability. So it doesn't replace safety, it's another addition. And then unfortunately, utilities, we learn during major events. So the 2003 blackout, which I'll discuss in great length in the class, that was a major issue that impacted the transmission system. So as a result, there was a need for transmission reinforcement, transmission enhancement. SCADA stands for supervisory, control, and data acquisition. So more metering, more data, more control. So that was another very, very important point. Fast forward, from the 2003 blackout in the East Coast in 2012, Superstorm Sandy, and this is the first time when the term resiliency became like a very popular topic. So you know, people define resiliency in different manners to make it very easy so you don't get confused. From a utility perspective, resiliency is merely uh, impact of Mother Nature. So, floods, flash floods, excessive rain, very strong wind that exceeded the utility design. In some areas, volcanoes, earthquake, wildfires, major hurricanes. So every utility, every state, every geographical area, they have a historical data that shows all the impact, all the disaster that they face, and their system is designed to handle those disasters. However, to give you a funny story, I was in a geothermal conference in 2024, and there was a question about, all this digging that's happening in New York, specifically Long Island. Are there any concerns with earthquake? The speaker said, this is New York, we don't get any earthquakes, and literally the next day we had an earthquake. So when you have a first-time event like an earthquake or wildfire in the East Coast, now you have to adopt your design. So after 2012 Superstorm Sandy, the focus has been on renewables, distributed energy resources, specifically solar and wind. And wind, you have onshore and offshore. So we had, a lot of states already have a very large penetration of onshore wind. It's offshore that is kind of at very early stages. So again, I want you to imagine from the utility, I keep adding to the menu: safety, reliability, transmission, resiliency, renewables, and in a way, your whole system must be able to withstand that. Then a very important point is cybersecurity. It's impacting everything we do. We're getting a lot of phishing emails, scam calls. People are trying to, go after your personal information, your financial information. So from utilities, a different perspective, because if you shut down the electric grid, the whole system would shut down. There'll be chaos. So how can we, by doing all this stuff and adding customer, adding solar, adding energy storage, still maintaining a cyber resilient system? And then after that, electrification, which basically means two things. There's electric vehicles. So, from a climate change perspective, which is the focus for this course, the transportation sector required a lot of attention. So utilities play and are playing a massive role by enabling electrification. So, every type of vehicle you could think about: small, medium, heavy duty, even planes and ships. So everything is becoming electric. That puts pressure on us because we have to make sure that we have enough power to charge all those assets. But on a very high level, electrification has a big impact on the grid that we address. Another type of electrification is known as building electrification. That's a fancy term for referring to electric heating. So a lot of homes, their heating is either through natural gas or oil or other entity. But for now, there's a conversion of all this fuel to electric. So again, you can kind of see that we're developing this electric basket when everything is becoming electric. So the electrification is playing a very big role, and the preparation for the grid. In some areas, as we convert, gas heating to electric heating, now all of a sudden you have an issue because some utilities, like in the East Coast, are expecting to transform from being a summer peaking utility to a winter peaking utility. That's like one. Or even worse, having like a camel hump when now they're gonna have a summer peak and a winter peak. So it's kind of very challenging because now, usually in the winter we do our outages work, we prepare the grid for the next summer. So, and there's a lot of issues you could think about. Just to give you an example, solar generation, during the winter, the sun rises late and sets very early. So that's another challenge that we have to address. And then after all this journey, ESG, or environmental sustainable governance, or climate change impact, became very critical. So pretty much the whole everybody in start thinking, basically think climate, as simple as that. That's kind of my slogan, to deal with people in the field and the office, standards, engineering. You're making decisions, supply chain, ordering equipment. So how can you basically transform the way you behave, the way you think, to be from an ESG perspective. So it's not an easy change, but is it definitely a change that we would like to address? Scopes 1, 2, and 3, which we'll discuss. And the school does a great job, and a lot of students are focused on that perspective. And then finally, the rise of artificial intelligence, AI, and data centers. For many years, energy efficiencies were doing a great job by reducing the customer bill, but now we're seeing an exponential load growth as a result of electrification and AI. So AI it's a great tool to help us do a lot of stuff more efficient. At the same time, to do stuff more efficient, we're using a lot more power. So that's a busy slide. Every aspect here could require its own course, but at least for this course, think ESG. Think how we could change every aspect of the utility. Capital expenditure, the operational maintenance, even safety, the way we plan from an ESG perspective. So just to show you why this is very important. So when we talk about climate change, the most polluting sector was the power sector. And for years, the utilities, the states, they did an excellent job by mainly doing two things: shutting down coal generation and enabling renewables. Now it's kind of a challenge, and that's the beauty of having this discussion nowadays, because of all the aggressive load growth, because of electric vehicles, data mining and data centers. In some locations, unfortunately, they're going back to reopen, repower coal generation because it's cost effective and the power plants still exist. Putting aside this, at least I want to show you from a renewable perspective, this picture shows a lot. In the bottom left, I remember I took this picture a very, very long time ago in California, and that kind of shows you something that, it wasn't the norm in New York or New Jersey, where I live and work, to see like, rooftop solar. So it's only when I was in California when I saw something like that. Nowadays, of course, every street almost has a solar panels installed. In the bottom right, you could see vertical panels and elevated panels. This picture is for in Williamsburg, New York. That's a movie theater. So you got to be very creative, and as you could see from here, if you ever been to like New York City, it has very, very busy roof. So there's not that much space you could put any solar panels. That's why you have to be creative by basically putting, as you can see from the picture here, elevated panels and vertical panels. Then you go to all the way to the right, top right. I took this picture a while back. That's actually in the Rutgers, one of the campus's parking lot. So I'm personally a big fan of the parking deck or the parking canopy. Think of it, if it's a very, very hot day, instead of coming back and your car is burning hot and the leather is extremely hot, you got the shade. If it's raining, it's great for the car. If it's snowing, again, great for the car. And then if you could pair and install like an electric vehicle charger, then you have a clean energy, completely renewable energy charging your car. So this is getting a lot of momentum. Of course, it's more expensive than just the rooftop because of all the foundation to basically hold the structures. And then kind of in the middle, some utilities like PSE&G, they installed the solar panels. So there are, thousands of installation, one panel per pole. Again, I always say if there is space, you will have solar. Then the picture on the top left, that's a very, very busy rooftop. As you can see, this, of course, are multiple buildings. So, the rooftop, the commercial rooftop is getting a lot of popularity. Of course, if you design it right, you could kind of see there's a lot of space on this roof, and they really optimize the space. Of course, there are challenges with the fire department and what happens if there's a fire. All the stuff must be addressed. But again, and then the picture in the middle, kind of on the top, you could see a solar farm, just acres and acres and acres of solar panels. If you look carefully, you're gonna see that there are no nearby load center, and that's kind of the case. Developers, they choose areas like southern Jersey when the land is relatively cheap, or it's like a wetland, and they have kind of a deal with the government or an incentive, and they install, tens of megawatts. So this is just a snapshot to address why we need to have a discussion today. So solar is great, of course. One important point to differentiate that the weather impacts a lot. So a zip code in California will have more solar irradiance or more solar generation than a zip code in New York and so forth. So we try our best to optimize the weather we have. We cannot control the weather. However, we could try to develop a very efficient, cost-effective installation to make use of the available sunny hours. So again, this is just a quick view of a major change, and you can kind of see how Rutgers is actually participating in enabling solar penetration and reducing the carbon footprint. I like this picture. We're going to talk about substation. Substation is a very important entity that allow us to go from generation, transmission, sub-transmission, distribution, and so forth. Think of it as a hub to change the voltage or the pressure between two different points. So I like this picture because number one, this picture is very close by substation, and as we're going to learn from the course, substation is the most important piece of land, period. It's very, very important. So the fact that utilities are able to, be nice enough to add solar panels in their most important, most expensive real estate, it kind of shows you the transition, that how important renewable is, that they are now including renewables even at the very dear to their heart equipment. This picture is very nice. You could kind of see it's a very clear sunny day, but there are some clouds, and we're going to see in the course how cloud have a negative impact on solar generation. This is the Garden State, a lot of trees, and trees and solar are kind of, I would say, inversely proportional. The more trees you have, the less solar generation, and so forth. You kind of see all the way to the left. Here you could see the distribution assets. Then you see the traditional transmission in the middle of the picture, the steel structure, and then on the right you see the monopole. So this picture is a great picture. It shows the transmission versus distribution, the impact of the weather, impact of the trees, and so again, this is the kind of information that we really dive deep into that would definitely help the grid. Now, I mentioned 100% multiple times. What's really interesting is in 2030, that tend to be the year when a lot of utilities, systems, cities, and states, it's like the checkpoint. It's like the 50%. So 50% clean, or 50% renewable. And that's going to happen very soon. But what does it mean, 100% clean, 100% renewable? So New Jersey is a 100% clean energy state. New York used to be a 100% renewable energy state. So both systems in the future would rely on solar, energy storage, onshore wind, offshore wind, geothermal, and stuff like that, hydropower if you have available. But so they share a lot of similarities. The one big difference between the two systems is that nuclear energy is only included in the clean energy system. So the first bullet here, when you hear 100% clean energy system, that's an indication that this system basically allows nuclear. So New Jersey has a very large fleet for nuclear. That's great because now you play a very important role by relying on this very clean available resource that's playing a big role now, especially with the electrification, data mining, and data centers. So again, I said New York was a 100% renewable energy system, and the prior governor, he kind of shut down very critical nuclear plants, but because of all the change in the weather and the importance of really having the need for all the energy storage for baseload generation, it seems like the current governor in New York, she's willing actually, and she announced opening up a new nuclear plant. So one important thing also that we discuss in this class is the role or the importance of the political opinion and direction, and how it's our job to find to engineer the politics field. So imagine a system in the future when you basically rely on wind and solar. If you have ever experienced this summer's been getting brutal heat waves. What's very common about every heat wave? Extremely humid, you can't even breathe. Very hot. It's kind of there's a haze in the weather. That means what? That means the solar generation is completely underperforming. It's not windy at all. You can't even breathe. So on the hottest day of the summer, when people are using the AC the most, solar and wind resources are kind of under delivering. So we need something to fill in the blanks. So energy storage, as you can see the picture in the bottom left, and even electric vehicles. So we talk about electric vehicles a lot, and the difference between energy storage and electric vehicles is the mobility. So one of the advantages of including electric vehicles in the mix that we're able to very easily dispatch EVs to the load center, to the pocket issue. I always give an example. Imagine, Times Square. If you've ever been to Times Square with a car, you probably pay a little bit under $100 to park your car. Very expensive. Imagine if the utility has an issue there, and they said, yeah, if you have an electric vehicle, you get free parking, and maybe we'll use, let's say if you have a 400-mile storage in your car or available mileage to drive, they will take 100 miles. So you go have fun, enjoy your time in New York City, don't pay for it, and all you're doing, you're really kind of utilizing. So it's kind of, mileage as a service, if you will. So that's really the point here. And I want to highlight FERC stands for the Federal Energy Regulatory Commission. It's basically like the forcing or the policy arm of the Department of Energy. So they come up with orders. So FERC Order 841 basically states that any utility, any system that proposes expansion, or for example, we have a project to address an overload or a voltage issue, maybe you want to build a new substation, add a transmission line, whatever, any project you're doing, instead of just approving a project like that, they want to make sure that the utilities, they evaluated the use of energy storage. For example, can energy storage help? Can they help address an overload, a voltage issue? Can they help, kind of bridge the gap until the substation is built? So it's a great, great order that would result in a very large number of energy storage being connected to the transmission system. FERC Order 2222, which we spend a lot of time talking about in the utility, it's amazing. It's a big change because FERC usually handles the 100,000 volt and above, the big towers you see along the turnpike. They rarely get involved in distribution. So FERC 2222, imagine your home and imagine your Rutgers campus, your Rutgers dorm. You are basically like a nano microgrid or a nano power plant. So if you have, it's an incentive for customers to install solar energy, energy storage, electric vehicle, smart thermostat, geothermal, the whole 9 yards. So any generation you're able to add, and any tool you have to control your load, you as a homeowner, as a resident, and as a business owner, you get to participate in the market. So imagine your house is competing with a nuclear plant. So that's really what FERC Order 2222 is forecasting to do. Change the design completely, introduces this new tool where customers, home, and businesses are playing a very important role and getting compensated for it. Imagine right now, for example, you're in school, at the same time you're making a lot of money by absolutely doing nothing, just relying on your resources, your solar, your energy storage, your fuel cell, your geothermal, your electric car, your thermostat, and even better, you may be on vacation for a couple of weeks or you go back home for the whole summer, but your home is still playing a massive role. So that's another change impacting the utility. So, I mean, when you think about like the basic human needs, really, what do we really need? We need the cheap power, or actually, so for some people, it's like free power, if you will. So that's kind of really interesting. The basic human needs are always like food, shelter, a job, safety, food, water, and so forth. So right now, if COVID taught us something, it's the importance of having electricity all the time, and then having internet. And notice I said cheap or free. For the public, electricity now and the internet is as important as water and pretty much food, because if you have no electricity and or no internet, you can't go to school, you can't do your work, and so forth. So we kind of came a long way by just merely paying the utility for our bill. And if we lose power, yes, it's not convenient, but that's not the end of the world. Now if we lose power, your whole life stop. Your phone, you can't even pay for your coffee, you can't even have a boarding pass. Your whole life pretty much stops. Sometimes you can't even enter your hotel because you're using your phone. So it's very, very important for us. And of course, just as I mentioned, it used to be that the basic human needs are clean air, pretty much food, clean water, safety, and shelter. And then on top of that, we added power and internet. And what's really interesting is, we can also talk a bit about microgrid, and it's kind of the ability for some customers, let's say a large campus, to disconnect from the grid if the grid is having any kind of technical issue, or operate in parallel with the grid, supply their own power. So for example, if a university has a large, cogeneration plant, solar storage, and the utility is going through an issue or they have a massive blackout, then some customers are able to disconnect and supply their own power. And then what they do sometimes, which is great service for the whole city, they develop like a safety. So, if a campus has a very large, for example, stadium, if it's an indoor stadium or an indoor auditorium, or just like a training center, if it's during the summer, they provide cooling. If it's during the winter, they provide heating, and you're able to come and basically enjoy, food in a safe place. So electricity plays, and we spend a lot of time talking about this kind of concept. And of course, from the perspective of students, as I mentioned before multiple times, the utility have transitioned a lot from purely jobs only for meter reader to every kind of major you could imagine. I deal with, globally, I mean, the very, very large, companies like the Google, the Amazon, the Microsoft, the large, consultant like McKinsey, Accenture, and so forth, the small startups. So pretty much everybody and everybody want to do business with the utility. There are a lot of room for innovation. I always, advise students to focus on programming, sustainability. So anything that any major, all majors are welcome, and there's a lot of room to grow. And now with the data centers that are promising to be, a major issue, or at least it could be an opportunity and load growth for the utility, there are a lot of advantages. And just imagine that AI just started, and already we're seeing this major changes. What's going to happen in the next couple of years? So it's definitely, again, just to summarize this slide is highlighting the importance that electric power play. That for many people, that they would basically rather include it as the basic human needs. And of course, it's not sustainable for utilities to provide electric power at no cost. But that's just kind of highlight the importance of something like that. And as we kind of touched in the previous slide, transportation. So from a climate change, the most polluting sector, as we discussed, with the power system, then the transportation and utilities did a great role by basically uh, cleaning up and greening the electric grid by the renewables and so forth, and shutting down coal plants, adding nuclear and so forth. So the next sector that needed to be addressed was the transportation sector, and the utilities, they play a very, very important role by basically enabling the electrification of various sectors. The small passenger vehicle, initially it was Tesla. Now there are a lot of electric cars, different brands, and in the class we don't just focus on New Jersey or the US. We talk about globally. There's a lot of Chinese made brands that are pretty much once you travel outside the US, you can't miss them. But again, it's electric cars is the transportation, the buses like New Jersey Transit, then the electric school buses. They play a very important role by being available during the summer. Then you have the massive trucks like the sanitation trucks, and then you have, of course, the Tesla Semi. Then you have the ports, let's say Newark ports, as they electrify these massive ships and ports, and then even the planes. So there's a lot of discussions about electric planes, and even the flying taxi. And then you have the whole e-mobility. If you've ever been to New York City, you see a lot of people, they are commuting using the electric scooter, electric skateboards, and so forth. So all the stuff requires reliable power from the grid. So, I like to kind of think from a perspective of, like a strategy. Again, here's a very nice picture of the MetLife Stadium, which is one of the most famous stadium worldwide, and it's a great place to host the 2026 World Cup final. So the whole world will be watching the soccer final game in the stadium. But the idea here is really to kind of discuss the transformation that we spoke about and what is the roadmap. So in a lot of places it's called integrated distribution plan or integrated resource plan. Really kind of what would we do from the perspective of customers and entities. So some utilities they're only electric, some are gas only, some electric and gas, some electric, gas and steam, some electric and water. So there's a lot of variety of, but the important point is all the sectors I mentioned are all important to customers. So hence, the transformation also included the customer. So instead of the customer, all their lives are just paying the utility because they are consumer, so they pay for the energy that they utilized. Now they are prosumer, so they are generating, as I mentioned with FERC Order 2222. So instead of just, here's the check to utility, actually receiving checks from the utility, from the state, from the regional transmission organization and the independent system operators that we'll discuss, ISO and RTO. So what does that mean? That means that you as a homeowner, your whole house, you think of it as a power plant. And the more assets that you're able to acquire, the more generation, the more you're able to pretty much earn. And instead of having a solar panel, for example, a system that may pay you back in like 8 to 10 years, now maybe it's in 4 years because you're gaining more momentum, you're gaining more revenue and other perspective. A very important point that I think kind of I mean, I had a privilege of working on a smart grid as early as 2007 under President Obama's stimulus. So smart grid plays a big role, and that's a great thing for the utilities and for the schools and the students because there's a big focus on the software and hardware. So that's why I always encourage to gain some kind of programming capabilities, whether it's Python or others. But as we're going to see in the course, it's not just hardware, raising equipment, putting more advanced equipment with advanced intelligence and sensors. It's also acquiring and installing the latest management system that would allow the utilities to better manage their generation, distribution, transmission, behind the meter for the customer's location, and so forth. Think of the FERC 2222 and how the utilities will be communicating to and from the large utility control room to your house and your business. And load growth, for many, many, many years, the load growth has been flat or negative as a result of energy efficiency. And now it's expected to be a massive load growth slope. We're talking about data centers in the gigawatt range. To give you an idea, the average peak for a house in the country is like 3 kW. And, 1 megawatt is like maybe 600 homes worth of load. And now imagine that we talk about 1,000 megawatt as the load for one data center. So multiply 1,000 megawatt by 600. That's how many homes equivalent load is one data center. So that's a lot. At the same time, climate change is here to stay. Whether it's 1.5 degree or 2 degrees, we have to do our best. Throughout this class, you learn a lot of tools that utilities are addressing ESG. So we have to make sure that even though the load is growing, that we don't lose focus and we don't lose all the success we've accomplished so far in various sectors, including the power, the transportation, the industrial sector, the commercial sector, the residential sector. So a lot of sectors that we are discussing in this course when utilities, especially in the US, have exerted great effort and great success. So the issue right now is, and that was an issue if you remember with data mining, all of a sudden there was a lot of noise in the news about how these systems are resulting in a very dirty generation and so forth. And now the future is unknown, but one thing for sure, you have a cost impact because at the end of the day, there are a limited number of ratepayers. The utilities are not, we're not like Wall Street. We don't have like unlimited budgeting. So you have to work with the rates with the customer we have. So you have to do it in such a way that is not kind of a burden for the customers. So you have to do customer affordability. You have to address, if you remember the journey I told you about, the safety, reliability, resiliency, cyber, AI. So we have a lot of stuff are being added to the utility kind of business as usual. So it has to be done in a very cost-effective, innovative way. So here's just a picture to give you an idea. This is, we're showing equipment. So you may have seen the picture on the right, on the left. This is known as a messenger cable. This is a more kind of reliable structure that you're able to go through the trees so you don't kind of lose customers if there's a tree branch that falls or something like that. So utilities again have been doing what's known as hardening to find a stronger cable. They have like basically something called the messenger holding them to prevent if a tree falls down, it's not going to touch the cable. It kind of touches this protective surface. You have equipment like the one on the right, known as a recloser. That's an entity that would basically, if there's an interruption and that interruption is momentary, you wouldn't lose the whole system for a while, just a momentary. So we talk about stuff like that. So utilities have been spending a lot of time, effort, and of course money to make sure that if there's any disturbance to minimize the number of customers interrupted. Instead of, let's say, for example, losing 5,000 customers, you'd only lose 500 and so forth. In the bottom right, you could see the picture of what's known as the cable, which is the underground circuit. So sometimes some overhead circuit have been converted to underground. Underground is very expensive. That's why we don't just convert the entire system. Also, you cannot see it, so it's harder to locate failures and faults when they happen. So they have to have like a balance between the overhead system and underground system. And then in the middle, this blue rectangles, they are known as relays. They are the intelligence of the grid. They detect any kind of I would say mishaps, and they react in a very, very quick speed to restore the system. Again, this is just an idea of the grid modernization that we discuss. Again, if you've been here during Superstorm Sandy, you know that the utilities, they lost a very large portion of their electric grid. And basically, the way Mother Nature works, we get hit, we restore customers, we learn about the impact, and we restore the system and build the system in a more resilient manner and wait for the next storm. So here's the best example. The utility was able to raise a lot of assets, like a breaker on the right side and a control room, a switch gear, as we're going to discuss. So again, if there's a water, and the good bad thing is we have a lot of floods, so we're able to always evaluate how well our hardening has been done. So this is a great picture to show the following of kind of state of the art kind of innovation to stand something like this. Here is the next level. So, hardening is one thing, but intelligence really. So I'm a big fan of using robots. You could see in the picture in the bottom left, the robot is doing a lot more by helping the employee. It could be like a check for the safety, so it tracks all kind of steps. It could reduce the impact of the O&M budget, because now instead of having like a two-person crew, you have one on a robot. The picture on the top, that robot does a lot more. It's like safety, because nobody's going to jump in to try to steal copper. If there's a robot that looks like this, you have cameras. It's kind of automated, so you don't have an external person running the robot. It also does, as you can see in the picture in the bottom right, like a LiDAR image, and it's always sensing and taking screens and images. Utilities have hundreds of substations, so you're able to optimize and reduce any kind of travel, and that kind of helps a lot from ESG perspective. Instead of having a lot of cars that burns gasoline or diesel, you're idling, there's possibility of having a motor vehicle accident. You send one or two person, they could drive multiple hours to get the substation, open the gate, close the gate, set up all this to do to take a picture or some kind of sampling. You got a robot that's automated, it charges its own self. So this kind of like the next vision of automation and kind of the using of the 5G kind of communication, and on top of that, using AI. So the sky's the limit to what utilities could do as well. So this is kind of a good summary since we talk about Jersey. So again, 100% clean energy, nuclear is included. The governor has advanced the goal from 2050 to 2035. It was already a very, very difficult goal. Now it was made a lot harder, because now we have 15 years less. And again, we're very, very close to operate a system in a reliable, resilient manner. And we always learn. I mean, there's in 2025, there was a massive outage in Spain and Portugal. The entire country pretty much shut down, both countries, and there's a lot of discussion. Is it because they have a lot more renewables? They don't have a lot of baseload generation. So without kind of making any conclusion, just wanted to raise the point that there's a lot of, it's not as simple as that. And if you shut down a power plant or decommission it, you can't just go and click a button. That power plant is gone. Renewables, they are everywhere. I showed you the picture of solar in every sector. So how can we accommodate even more renewables without negatively impacting the grid? With FERC Order 841/2222, which is a lot of storage, solar, EVs, the whole nine yards, the utility, instead of working with maybe 10, 15 power plants, now they're working with 10, 15 million homes on a day-to-day, hour by hour, minute by minute, and then a cloud comes in, and then your solar generation is no longer available. Electrification, again, you can't help by seeing the amount of people that buy electric cars, the buses, the whole nine yards, the Amazon, all the trucks now are almost electrical. The United States Postal Service. So this massive electrification, how can the grid be ready? And then remember the transportation. We do all the stuff to lower the emission from transportation, but you don't want to lower the emission from transportation by adding more coal generation to supply the electric. That's kind of also like an issue you have to discuss. What is the balance between adding a lot more electric vehicles at the same time the baseload generation must be kept clean? Energy efficiency has been doing a great job, but we got to do a lot more, because we're competing with something like data centers, like very, very aggressive load that is mostly flat. It's not just the load growth; it's accelerated. A lot of data centers, they wanna pretty much run. They want to be built as soon as possible. They do have the funding, so funding is not a critical issue for them as well. So, and then weather forecast is very important. Weather forecast is kind of like basically two aspects. One is better weather, so we know like the heat waves, the cold fronts, and so forth, and then the disaster forecast. If you ever worked in a emergency support related kind of entity, it's always you have two forecasts completely conflicting. One of it, no problem, the storm is not going to hit. The other one is, oh, it's Armageddon, you're going to lose all your assets. So utilities now have been installing their own weather stations, and instead of just relying on like weather.com to have intelligence, and AI is going to play a big role I showed you a very quick slide on the smart grid, the software, hardware. I mean, smart is a very relative term. So you want a smart grid, then a smarter grid that's basically learning. And in my opinion, it's all about an intelligence grid. Intelligent grid is a grid that basically operates on its own. You have the autonomous nature. When they say that person is intelligent, he or she, they develop stuff has not been developed. They have patents. So we want to get to the point when the grid almost on autopilot in a very reliable manner. So as you kind of see, we have a lot. It's going to be a very interesting course. It doesn't focus a lot on the formulas. It literally bridges the gap between all the theories you've been learning. It bridges the gap between all the sustainability, scopes 1, 2, and 3, and we all act together like utility experts. So once you're done with the course, you learn about generation, transmission, distribution, behind the meter, electrification, renewables. You gotta learn about all the aspects of the utility. We kind of work together from an ESG perspective. It's almost like as if we are in charge of the utility. How can we increase the ESG kind of awareness? How can we have a system that is very, very clean compared to others and to address future challenges? So, again, looking forward to working with you on this great course. And, we address, we do a lot of projects, individual group projects. I'll give you a lot of life examples of events and disasters and how we address them. So, best of luck and see you soon.